Good morning, students. My name is CH.S.V.PRASAD, and I am working as senior lecturer in Tripoli at Government Polytechnic Yadgirgutta. As we are handling the subject AC series AC motors, in this case, we are continuing the chapter 4, that is characteristics of three-phase induction motor. In this case, we are covering how to draw the circuit diagram by using no load test and blocked rotor test. In the last class, we have explained how to draw the circuit diagram. So from that circuit diagram, to drawing the circuit diagram, what parameters we require, that is which test result we require, that is no load test and blocked rotor test. From this parameter, how we can calculate the required values. We have covered that. So today we will see some problems on circle diagram. So he given a problem of draw the circle diagram for a three phase H for a 5 HP 200 volts three phase 4 pole 50 Hz star connected induction motor for the following data. So what he given? He given no load test and blocked rotor test. So he given no load test readings as 200 volts, 5 amps, and power factor cos pi as 0.202, and short circuit test as 100 volts, 26 amps, and 1700 watts. So from this circle diagram, we have to calculate line current and power factor at full load, and next maximum torque and starting torque in terms of full load torque. So, and next we have to calculate slip at maximum torque and assume rotor copper losses standstill is equal to half of the rotor copper losses. That is, rotor copper losses is equal to half of the total losses. So, so both are at half. Rotor copper loss half of that means both are 50-50% both. So we have to draw the circle diagram. So before drawing the circle diagram, we have to note down the values. So what is the given values? From this we have to draw the circle diagram. First note down the values. The given circle diagram of 5 HP. So, and what is the voltage? Voltage is 200 volts and star connected, and no load voltage, that is V is equal to 200 volts and I naught is equal to 5 amps, and cos phi is equal to 0.02, and short circuit current ISC is equal to 26 amps, and voltage VSC is equal to 100 volts and power is equal to 1700 watts. So these are the given data we have to write. Note down this problem. So from this we have to calculate line current and power factor at full load, maximum torque and starting torque in terms of full load torque, slip at maximum torque. So first from no load test we have to calculate the phase angle. So that is pi naught is equal to cos inverse of 0.02. So that is equal to 78 degrees. So next we have to given the no load current I naught is equal to Ia. So that is 2 centimeters. So we have to draw. So we assumed 1 centimeter is equal to 2.5 amps. So I naught is equal to A. So that is 2 centimeters. So why? Because I naught is given as 5 amps. So now we have to draw I naught, that is OA, at an angle of 78.35 degrees. So V1 is equal to I naught at an angle of pi naught. So here we have to take x-axis and OY as y-axis, that is voltage vector. So we have to draw I naught at an angle of pi naught. So by drawing this one as shown in figure, that is OA, that is IA I naught at an angle of pi naught. So at an angle of pi naught. Next we take block rotor test. So here he given ISC is equal to 26 amps at 100 volts. So first convert this current to 200 volts. So that is short circuit current with normal voltage. So ISN is equal to ISC is into V1 by PS. So that is 26 into 200 by 100. That is 52 amps. So ISN is equal to, so now you divide 52 divided by current scale. What is the current scale? Current scale is 2.5. So 52 by 2.5, that will gives 20.8 centimeter. So next, short circuit power WSC is equal to root 3 into VSC ISC into cos SC. So from this we can get the short circuit power. So after getting this short circuit power, we have to draw ISN, that is OB, that is at an angle of 67.82. So what we have to draw now? We have to draw OB at an angle of pi s, that is 67 degrees, that is OB. So now join A and B and draw a parallel line from point A parallel to OX, that is OD, as shown in figure. So these things we have to calculate from no-load test and blocked rotor test. From no-load test, we have to take no-load current and no-load power factor. And in short circuit test, we have to take short circuit current and short circuit power factor. By taking that, we have to draw vector OA and OB. Then you join A and B. So after join that, from A you draw a parallel line that is parallel to OX. Parallel to OX. So after drawing this OX parallel line, now we got a point A and B. A and B. Now what we have to do? We have to bisect the line AB. We have to bisect the line AB. So to bisect the line, what we have to do? We have to take the radius, which is we have to take the compass, and the radius is equal to more than half of the length AB, and draw a arc A as center on both AB. Both sides you draw one arc. Then with the same radius B as center, and you draw arc on both sides so that it cuts the previous arc. So then what happened? You will get 2 points. Join these 2 points and extend it so that it cuts the line AD at a point C. So where C is the perpendicular bisector. See here. So first we have to bisect the line AB. How we will do bisect the line? Take a compass and radius is equal to more than half of the AB and A as a center, and radius is equal to more than half. Draw arc here and again draw another arc at the bottom with the same radius B as center. Draw another arc which cuts these two arcs. Then join these 2 points. And while you are drawing these 2 points, that line passes through a line AD which cuts the point at C. Now C as center, AC as radius, and draw a semicircle, that is ABD. That is a semicircle. So if you take C as center and AC as radius, and if you draw a circle, semicircle, that point passes through a point B. So that is a semicircle ABD. ABD. So the total short circuit power at normal voltage, so that is WSN is equal to short circuit power into V1 by Vs whole square, or that which gives the short circuit power. So that is 1700 into 200 by 100 whole square. So that is 6800 watts. So this power is equal to the length of Bg as shown in figure. After drawing this, I will show the figure once. See here, after drawing this semicircle, you draw parallel line from A and B, vertical lines. That represents the power which is equal to length Bg. Measure Pg. So that is 7.9 centimeters. So already we calculate the short circuit power, that is 6800. So that is divided by 7.9. So that will give us 860 watts. And rotor copper losses at standstill is equal to half of the total copper losses. So now BF is divided into two parts. How we have to divide? Where BF shows the rotor copper losses and stator copper losses, such that BE is equal to EF. BE is equal to EF. So that is center point of BF. So that is we divided the both rotor copper losses and stator copper losses as equal. So after getting this point E, you join the line AE, which gives a torque line. So we have the full load output. So that is 5 HP is equal to 5 into 735.5, which is 3677.5 watts. So which is nothing but a BL. So BL is equal to that power divided by the power scale. What is the power scale? Power scale is 860. So that is 4.27. Now we have to extend the line from point B at the top. So that is which gets a point L. So that is BL is equal to 4.27. So after getting this BL, we have to calculate cos phi s, that is 67 degrees. Okay, next now BL is 4 centimeters and produce BG such that BL is equal to 4 centimeters. Now from point L, draw a parallel line which is parallel to output line and cuts the circle at point P. So OP represents the, after getting this point, joined center O and P. So OP represents full load current. So now to draw a semicircle with radius as equal to AC, consider center at point C and also draw a line PL which is parallel to the AB as shown in figure. Everyone note down this figure. Note down this figure. Here it shows first how to draw the graph, circle graph. First we have to take a graph sheet and draw y-axis and x-axis. So the y-axis OY, the x-axis y-axis OY represents the voltage vector. For this voltage vector, first we have to draw OA, which is equal to I naught. So first we have to draw I naught, and first we have to calculate I naught and pi naught can be found from no load test. So now next we have to choose proper current scale and draw I naught, which is represent OA lagging behind V1 by angle pi naught as shown in figure, with applied voltage V1 as vertical reference axis. So from this blocked rotor test, ISC is known as short circuit current, and convert this short circuit current to normal voltage level, that is ISN. So ISN is equal to IS into V1 by Vs. So cos phi s is equal to Ws by Vs by Is. So ISN is equal to short circuit current corresponding to normal voltage. So with the same scale, the vector OB represents ISN at an angle of pi s with vertical axis. The vector AB represents rotor current as referred to stator. The 2 points A and B lies on the circle. So to find the center of the circle, draw perpendicular bisector from the line AB. So this will cut the horizontal line AD drawn from A at C with C as center and C as radius. Draw a semicircle A, B, D. See here. So V1 is the y-axis and OX is the x-axis. First, you draw OA at an angle of pi naught. Next, OB at an angle of pi s, and joined these two A and B. Now after joining AB, bisect the line AB by taking compass and A as center and radius is equal to more than half, and draw curves on both sides of the AB on the top and bottom. Similarly, B as center and with the same radius, draw two arcs which cuts these two arcs, top and bottom. Then join these two lines as shown in figure as a dotted line. So after joining these two lines, so this line passes through a point C which cuts the AD line. So C as center and AC as radius, draw a circle, that is ABD. ABD as a semicircle. Here we have to note one thing. Here when we are drawing AC as a radius, C as a center, then the point B also passes through this semicircle. That means the points A and B both lies on the semicircle. So after drawing this, we have to extend this. From B you draw a vertical line, and from A also you draw a vertical line. This B touches the x-axis at G and AD at F. So this BF represents the rotor copper losses and stator copper losses. But in our problem, they given both losses are equal. So take the midpoint of BF, that is E, and join this AE, which gives a torque line, and AB represents the output line. Now you calculate the short circuit current and power scale and add the output power as we calculated. So which is BL is equal 4.27. Extend this BG line towards up to get a point L. From this point L, you draw a parallel line which is parallel to AB. When you are drawing this parallel line, it cuts the semicircle at point P. So from point P, you join the center O. So that is OP, where OP represents the full load current. So, so how we can put this? That is, we have to get the point E such that B is equal to EF. Here, you see here, BE must be equal to EF. Both are equal, and E as now. So that is E is a center point and join the E and A. When you join AE, which represents the torque line, and AB represents the output line, we have to take such that BE is equal to EF. So, to getting that point P, you have to join OP. After join this OP, you can measure this angle. So that is pi s. So that is pi 1. So after getting this pi 1, you measure, and so that is nothing but a no load phase angle. No load phase. Cos of that angle gives the full load power factor. So if we suppose the problem to calculate the Mason torque. To calculate the Mason torque, we have to draw a line that is parallel to torque line AE and tangent to semicircle. Then you will get a point. Which point we will get? We will get a point F. So from F you draw a vertical line until the torque line which touches at a point G, where Fg represents the Mason torque and AB represents the torque line. So the Mason torque is also known as stalling torque or pull-out torque. So suppose if you want to calculate maximum output, so first we have to know which is the output line. Output line is AB. So now we have to draw a line parallel to output line AB and tangent to semicircle. So which touches the line at a point H. From H you draw a vertical line which touches the output line at point I. So HI represents the maximum maximum output. So you measure that output and multiply with the power. So so then you will get the measurements. Here, after getting this phase angle, we have to measure that angle, that is 32. So cos of this angle, which gives the 0.85 lag. So next calculate the synchronous speed. What is the formula for synchronous speed? So that is 120 F by P. So that is equal to 120 into 50 by 4. So that is 1500 RPM. So so just now I explained how to get the maximum torque. To get the maximum torque, we have to draw a line which is parallel to torque line, that is AB, and tangent to semicircle. So which gets a point R. From R you draw a vertical line up to torque line AB. So that is S. So measure RS, which is 7144 synchronous watts. So full load torque is equal to full load rotor input. So you measure the length Pn. So this Pn is equal to full load torque. So which is nothing but a 4.45 centimeters. So starting torque is equal to rotor copper losses at standstill. So this starting torque is nothing but a BE. Measure BE, which gives a length of 3.75 centimeters. So, likewise, HI is the maximum output and RS is the maximum torque. So where B represents the rotor copper losses and EF represents stator copper losses and FG represents fixed losses. So HI represents maximum output, RS represents maximum torque. So AB is output line and AE is torque line. So we have to draw a line which is parallel to this torque line and tangent to the circle. So that touches a point R. From R you draw a vertical line which touches the torque line at point S. So RS represents maximum torque and HI represents maximum output. Maximum output. So likewise, how you will get maximum output? Which is the output line? AB is the output line. We have to draw a line which is parallel to this output line AB and tangent to circle which touches a point at H. From H draw a vertical line which touches the point I. So HI represents maximum output. So maximum output is equal to HI is equal to centimeters. So multiply with power power scale, which gives the maximum output. So from this, from point P, you draw a vertical line which touches the line at point K. So while it is touching at K, it cuts the output line at point M and torque line AE at point N and AD line at point J. So now the what points we got? So in between PK we have got M, N, J. So after getting these points, so we can calculate. So this completes the circle diagram. After drawing this circle diagram, we can calculate the required values. So after getting this, note down this. So to get the maximum torque, to get the maximum torque, measure RS, which is 8.3. So to get the ratio of maximum torque to full load torque, so you measure maximum torque value, that is RS, and full load torque value already be calculated, that is 4.47. So 8.3 by 4.47 is equal to 1.87. Next, starting torque by full load torque. So starting torque, you measure the starting torque, that is 3.75 divided by 4.45, which gives a value of 0.84. So next, he asked to calculate slip at Mason torque. So that is Ts by Rs. Measure Ts. How much he given? He given 1.7 divided by 8.3. 1.7 by 8.3, which gives a value of 0.2. So after getting this, short circuit current ISN is equal to ISC into V1 by VSC. So short circuit power is equal to root 3 into VSC ISC cos pi SC. So pi SC is equal to WSC by root 3 VSC into ISC. So synchronous speed NS is equal to 120 F by P. So we have calculated from this circle diagram the parameters which is required, that is full load current. That is how we can get the full load current, by measuring the distance OP. So you measure the distance OP, you will get in centimeters and multiply with current scale. Next, slip is equal to rotor copper losses by rotor input. So that is Ts by Ps. So that is 0.4 divided by 3.4. So which gives the slip. So after getting the slip, as we know the uh, sync as we know the synchronous speed ns, that is 120f by p, we can calculate the rotor speed at any desired rotor speed. Then again we have to, if suppose if you ask to calculate rotor copper losses, then we have to follow the same procedure as it given. So after that, next we have to, so before drawing the circle diagram, we have to conduct the no load test and block rotor test. So after getting the values from this no load test and block rotor test, we have to check either the short circuit test is at rated voltage or not. If it is the short circuit test short is not at rated voltage, then we have to current the convert the short circuit current to the rated current by using this formula, that is ISN. So ISN is equal to IS into V1 by VSC. So after calculating this slip also, what is the slip formula given? Slip is equal to TS by PS. So that is rotor copper losses by rotor input. So after getting this slip, rotor speed NR is equal to NS into 1 minus S. So which gives the rotor speed at a given value. So suppose if you require measure torque, measure Fg and multiply with the power scale. Suppose if you required full load output, then measure the distance PQ in centimeters and multiply with the power scale. So to draw the circuit diagram, we require short circuit test and no load test. So from no load test, so what we can calculate? From no load test, we can calculate friction and windage losses, core losses in the stator, and the copper losses in the stator. Next one is locked rotor test. In locked rotor test, what we can do in locked rotor test is nothing but a short circuit test, which is similar to a transformer. In short circuit test, we have to apply the normal voltage and take the readings of wattmeter, ammeter, and voltmeter. So from this we can calculate total distance and total reactance of the circuit. So after calculating that, we have to measure both. We have to measure uh, both voltmeter, ammeter readings. After getting that, we have to draw the circle diagram. The circle diagram is very important. We have to do practice. If you do practice 2-3 problems, then it is easy to identify, and we can solve. If we not, then if we not practice, it is difficult to do in examination. Okay, this one for this one is only the solution is practice. How you do the practice so lot, then we can do the problems. The only the advantage of this circle diagram is by drawing this circle diagram by using scale, you measure any length, and after measuring that length, you can find the values at the required values, which is given in the formulas. By using these formulas, we can calculate. So, so likewise, we can draw the circle diagram and we can calculate the required values. You did this problem. If you have any doubt, ask me in the next class. Okay. Thank you.